Sir, you started, sir? But zero.
No one is no. There comes one.
స్టార్ట్ చేయండి అక్కడ ఉండాలి కదా. Shall I wait 5 or 10 minutes?
7 viewers.
Yeah, good morning, children. You are able to hear my voice, children? Just to check it, sir. Children, you are able to hear my voice? Yeah. Okay. Last class, I have given few numericals in empirical formula and molecular formula. You remember, children? And I have given few problems. Actually, 11B children, I didn't start what is the precision and what is the accuracy. But I have given that part in the holiday homework. Okay. But 11C children, already I completed that topic and significant figures also I completed. Just to complete this holiday homework, first part, what is the precision and what is the accuracy, just I will repeat that once again. 11C children, you are able to hear my voice? Okay, children. What is the precision and what is the accuracy? This is a, definitely you will get in examination 1 mark question, what is the precision and what is the accuracy. Okay. For example, what is the accurate value? Okay. For example, in one burette, already you know what is a burette. In laboratory, you saw this apparatus, what is a burette and what is a pipette. In this burette, suppose this is a one apparatus, here we are pouring some acidic solution. Already in the lower classes, you studied acid and base. Whenever it react with each other, you will get salt and water. Okay. So in one burette, I have taken acid. For example, HCl I have taken. Okay. And in one cortical flask, I have taken base solution. Base, maybe it is a NaOH, sodium hydroxide solution. Okay. Now, when this acid is reacting with base, you will get salt and water. So how you will get salt and water? So HCl is reacting with NaOH and you will get NaCl and water. But both are colorless solution, children. Acid is a colorless solution and base is a colorless solution. Then how you will know the salt is formed? So for this we will add one indicator, that is called the phenolphthalein indicator. So whenever you add phenolphthalein indicator, immediately the color will change to pink color. But when this titration started, acid and base, the pink color will disappear and the colorless solution will form at particular point. So immediately you have to stop this law, and that particular point we will call it as a end point. So end point generally, for example, whenever I am doing the titration, the end point is exactly 20 ml, 20.0 ml I got. Okay, so this is the true value. But when you are doing the experiment, okay, when you are doing the experiment, you will get exactly 19.9 ml, and second time you are getting 20 ml, and next time you are getting 20.1 ml. Whenever you are doing the titration, okay, so immediately what we will observe, these two student got almost the accurate value. Okay, because the true value is 20 plus or minus 1. If the student will get plus or minus 1 value, we will tell it is an accurate value. For example, exactly 20 ml if you get, that is 100% right. Even if you get 20.1 also fine. Even if you get 19.9 also, you will get full marks. Okay. Suppose another student, first time he got exactly 20 ml, but next time he got 23 ml, and next time he got 25 ml on titrating value. So this student is not getting any accurate value. Then what is a precision? Precision means, for example, one student got 19.5 ml. Next titration he got 19.4 ml. Another time he got 19.3 ml. Yes, for this student I have to give the full marks. Maybe these values are not matching with the true value, but still he is getting the precise value. Means whatever value he is getting, that values are very close to each other. Then we will tell it is a precise value. And this is not either precise value nor true value. So we will tell these values. This student will not get good marks. Maybe out of 10 I will give 3 marks. Okay, because it is not exactly true value and it is not exactly precise value. Maybe one value is correct, but whenever I ask to do the 3 titrations, this 2 titration value, a lot of difference is there, so he will not get full marks. But this student, yes, I have to give marks because all his values are very precise value. This student, definitely he will get 100% full marks because it is an accurate value plus precise value. This clearly is given in your textbook. See page number, children. What's the page? Page number 9. Page number 9, it is given what is the precision and what is the accuracy. So please, after significant figures, it is given precision refers to the closeness of various measurements for the same quantity. However, accuracy is the agreement of a particular value to the true value of the result. Please, all of you see the table. Student A, B, C. Student A got 1.95 and second time he got 1.93. So they are given the average value. Next is student B, there is a lot of variation. 1.94 and 2. Please don't see the average. You see the first and second value. Second time he got 2.05. Okay, there is a lot of variation. And student C also 2.01 and 1.99. So here also the value, the true value here, it is a 2 grams. See the first line, page number 9, first line it is given only 2 grams. So, but this student C got the correct value because the true value is 2 grams, okay, and first value he got 2.01 and next value he got 1.99. So, student C will get accurate value and it is a precise value also. But student B, it is neither precise nor accurate value because 1.94 and 2.05, there is a little variation. But student A, he got 1.95 and 1.93. So the values are very close. So student A also will get the mark. So accuracy and precision both are 1 mark question, very, very important, right? Significant figures already I completed in 11C. Okay, so for 11, but holiday homework I will give the significant figures. Okay, now I will start this. Even 11C I completed this law of chemical combinations. Okay, I completed this atomic mass and what is a molecular mass and formula mass. So molecular mass and formula mass is The difference already I told. Molecular mass means what? For example, I am asking what is the molecular mass of glucose. So what is the formula of glucose? C6H12O6. Right? So what is the molecular mass of glucose means you have to write each carbon atom weight is 12. Yes or no? So 12 into 6 you have to write, and each hydrogen is only 1. So how many 12 hydrogen atoms are there? So 1 you have to write, and 6 oxygen atom, each oxygen atom is 16. If you calculate everything, the final one is 180. So this is molecular mass. But the difference between molecular mass and formula mass is, there is no much difference, but formula mass generally we will use for ionic compounds. Ionic compounds example is what? Whichever compounds, whenever you dissolve in water, they will form cations and anions. But glucose, if you put it in water, it will not give any ions. Yes or no, children? So, formula mass, for example, if you take sodium chloride, each sodium atom is associated with 6 Cl atoms, and again each Cl atom is associated with 6 sodium atoms. It is given in your book, please check, but it is a 3-dimensional picture. So it is not possible to draw the structure on board, but just you go through once, it is a 3-dimensional structure. So here also sodium is atomic number 23 and chlorine is 35.5. So if you write, it is a 58.5. So this is actually molecular mass of sodium chloride, but using of molecular mass we will tell it is a formula mass, but there is no difference. Only thing is, for ionic compounds, we will use that word formula mass. Is it clear, children? Right. So some examples are given in your book. Just go through once. Right. So last class I completed what is the percentage composition and related numerical problems I completed, and empirical formula and molecular formula. What is the empirical formula? It is a skeletal structure. Once again, just 1 minute, I will explain what is the empirical formula. For example, benzene is C6H6. Okay, but if you write the empirical formula, you have to write only the skeletal structure. That is CnCH. Okay, this is called the empirical formula of the compound, but the molecular formula of benzene is C6H6. For example, I will tell one more empirical formula. How you will write the C6H12O6 empirical formula? So here it is 2 times. So it is a CH2O is a empirical formula of glucose, but molecular formula of glucose is C6H12O6. So you have to write the skeletal structure of the compound. It is called the empirical formula. Okay. And related numerical problem, the table I have explained how to do, and 2 numerical problem also I have given. Just go through once. Next is stoichiometry and stoichiometric calculation. This part is very, very important, children. All of you see page number 17. Yeah. What is the stoichiometry and stoichiometric calculation? See, children, suppose any chemical equation, if you write, in general way, how we will write? We will write the reactants and we will write the product, right? In lower classes, how you will write? First, this compound, we will call it as a reactant, that is left hand side. Right hand side, whatever compounds we will write, generally we will call it as the products. Okay, second step is balancing. How you balance the chemical reaction. Okay, children. Next one, you have to write the physical state of the compound. For example, in this case, physical state compound, methane is a gas, right? And oxygen is a gas. and carbon dioxide is a gas. And water, it may be liquid or vapor phase, but in this equation, it is a gas phase. So, whenever you want to write any chemical equation, first step, please write down the reactants and products clearly. Okay, second step, you have to balance the chemical equation. Third step, you have to write the physical state of the reactants and product. Is it clear? But in normal way, wasting of time. So we will avoid to write the physical state of the compound, but writing the chemical equation and balancing the chemical equation is must. Next, how we will calculate these compounds? For example, here nothing is there. I want to calculate this chemical equation using moles. Okay, using moles. Then how I will explain? 1 mole of methane is reacting with 2 moles of oxygen and it forms 1 mole of carbon dioxide and 2 moles of water. Suppose if I want to explain in moles, number of moles. Is it clear, children? Right. Suppose I want to explain in molecules. First one is moles, second one is molecules. How you will explain using molecules? 1 molecule of methane is reacting with 2 molecules of oxygen and it is forming 1 molecule of carbon dioxide and 2 molecules of water. Suppose if I want to explain in molecules. Okay. Now I want to explain same equation in grams. Then how you will explain in grams? 16 grams of methane. How you will tell it is a 16 grams? Carbon atomic weight is 12 and 4 hydrogen atoms. So each hydrogen atom is 1. So 4 hydrogen atoms, it is a 16. And 2 oxygen atoms. Each oxygen atom is atomic weight is 16. But 2 to 4. So 16 into 4, 48. 16 into 4, 37. 64. Okay. And next, carbon dioxide, how you will calculate the molecular mass? Each carbon atom is 12. 1 carbon atom and 2 oxygen atoms, 16 and 16. Okay. Then it is a 44. Right? And water molecule, 1 water molecule is 18. Yes or no? 1 oxygen atom, 16 and 2 hydrogen atoms, 2, it is a 18. But 2 is there, so 18 into 2, it is a 36. Okay, now I will explain it. Suppose, same equation, I want to say, like grams, how I will explain. Then I have to say, 16 grams of methane is reacting with 64 grams of oxygen and it is forming 44 grams of carbon dioxide and 36 grams of water. Is it clear, children? Right. First I completed number of moles. Next molecules I completed. Grams I completed. Grams please write down clearly. Grams related numerical problems generally you will get in examination. Please, children. Right. Next one I want to tell the same equation using liters. How you will explain liters? Generally, 1 mole we will represent it is a 22.4. Okay, this is a standard value, right? So 22 point. See, this is a 1 mole. So 22.4 liters of methane is reacting with, okay, 22.4 liters into 2. Okay, because here it is a 2 moles. So 22.4 into 2 liters of oxygen and it is forming 22.4 liters of carbon dioxide and it is forming 2 into 22.4 liters water. Okay. So once again, I will explain moles, molecules, grams and liters. Suppose you are taking one chemical equation. Using this chemical equation, please explain using moles. Number of moles means you have to explain 1 mole of methane is reacting with 2 moles of oxygen and it is forming 1 mole of carbon dioxide and 2 moles of water. Right, put tick mark. Second student I will ask, explain using molecules. Then that student should tell 1 molecule of methane is reacting with 2 molecules of oxygen and it is forming 1 molecule of carbon dioxide and 2 molecules of water. Nothing is there means 1 molecule or 1 mole. Okay. Next, third one, grams. Another student I will ask, using this equation, please explain in grams. So that student, he has to tell 16 grams of methane is reacting with 64 grams of oxygen and it is forming 44 grams of carbon dioxide and 36 grams of water. Another student I will ask, same equation, explain in liters. Because 1 mole is nothing but 22.4 liters. Then that student, he will tell 22.4 liters is reacting with 22.4 into 2 liters of oxygen and forming 22.4 liters of carbon dioxide and 2 into 22.4 liters of water. Is it clear? Now all of you see. Page number 17, it is given clearly, just go through once. The equation also it is given. Yeah. And page number 18, please all the 4 points, highlighted points, it is given with 1 mole and 1 molecule and 22.4, sorry, 22.7 it is given, but actually it is at 22.4. Okay, then 16 grams, everything it is given, just go through once. Next, I will read the problem, problem number 1.3. Calculate the amount of water in grams produced by the combustion of 16 grams of methane. Okay, suppose, how you will write? Combustion means what? Same equation. Combustion means it is the same equation. 16 grams of methane, whenever it combustion means in the presence of oxygen, how many grams of water is forming? How many grams is forming? 36 grams. Is it clear, children? 16 grams of methane on combustion, you will get how many grams of water? Because you are getting 2 H2O. Each water molecule is 18. So 18 into 2 is 36. So easily you will write, it will give 36 grams of water. Not more, not less, because it is a complete balanced chemical equation. Is it clear? Right. Next one. How many moles of methane are required to produce 22 grams of carbon dioxide after combustion? See here, please underline how many moles it is given, but answer they are asking in grams. Okay, children? See, 1 mole of methane is giving how many moles of carbon dioxide? 1 mole of carbon dioxide, right? But carbon dioxide molecular weight is 44. Is it clear? Now, they want only 22 grams of carbon dioxide. Means how much methane you need? 0.5. Yes or no, children? 0.5 mole means you will get 22 grams of carbon dioxide. Suppose if you take 1 mole, you will get how much of carbon dioxide? You will get 44 grams. Is it clear? See, 1 mole means you will get 44 grams. Same thing. 1 mole, you will get 44 grams. Suppose if I take 0.5 moles of methane means I will get only 22 grams. But your book it is given little complicated way. Just write down the equation and finish the problem fast. Okay? Right. Right. Limiting reagent. Limiting reagent related numerical problems. Whenever you come to school, I will explain clearly. First, I will tell what is the definition of limiting reagent. Right. Limiting reagent. Yeah. For example, I want to prepare ammonia. Okay. So how you will get ammonia? Nitrogen. Whenever it reacts with hydrogen, you will get ammonia. Right? Then I will ask the lab assistant. Now children, they are coming. Please prepare ammonia gas. They want to do some reactions using ammonia. Then suppose if I am not telling how many moles, generally lab assistant what she will do? She will take little nitrogen, she will take little hydrogen, and she will mix. You will get ammonia. But she don't know how many moles of nitrogen and how many moles of hydrogen she has to take. Until if I am not telling, sometimes it may be excess or sometimes it may be less. I will tell you that. Now, what is the original equation? N2 plus 3H2 gives 2NH3. This is a perfect equation forming of ammonia. Means, for example, you have to take 1 cup of nitrogen or 1 mole of nitrogen. In normal language, I will tell. Take 1 cup of nitrogen and mix 3 cups of hydrogen and you will get 2 cups of ammonia. Means almost the product, complete product you will get. Otherwise, 1 mole of nitrogen reacts with 3 moles of hydrogen and you will get 2 moles of ammonia. Here 99% you will get product. Suppose the lab assistant, she has taken only 1 cup of nitrogen and 1 cup of hydrogen only she has taken. Or 1 mole only she has taken. Yes, you will get ammonia. But what the yield? The yield you will get ammonia is very, very less. I think you will get maybe 40% of yield. So in this compound, hydrogen is very, very less you are taking. Hydrogen actually you have to take 3 cups. But how many cups she has taken? Only 1 cup she has taken. You understand? So in this equation, nitrogen we will call it is an excess compound. And hydrogen is very limited. Actually, according to original equation, she has to take 3 moles. But how many moles she has taken? Only 1 mole she has taken. But nitrogen she has taken same. Okay? Original equation also nitrogen is 1 and final equation also she has taken 1 cup or 1 mole. So nitrogen point of view it is correct. But hydrogen instead of 3 she has taken only 1. Means what? You are getting ammonia. But ammonia the yield is very, very less. You understand children? She has to take 3 cups or 3 moles. But she has taken only hydrogen is very, very less. So we will call in this case hydrogen is a limiting reagent, means very less compound, but nitrogen is excess reagent. So related to numerical problems, whenever you do, you will understand clearly. So the final thing is we should not use any chemicals. We should not waste the chemicals. You understand children? We should not waste any chemicals. Even food, whenever you eat food, the food you should complete properly. Suppose the leftover is there, it is useless. Even in chemistry also, each and every, because each chemical is very high costly material. So you have to see the chemical equation properly. According to that, you have to mix the reactants. Then only you will get the exact compound, 100% yield you will get. Unnecessary, if you are adding this and that, you will get the compound, you will get the final product. But some reactants are, they will not react, they will be remain in the as it is. So this is called the limiting reagent and this is called the excess reagent, right? And related numerical problems we will do later. Right, limiting reagent, I will read definition, please underline. The reactant which gets consumed completely, limits the amount of product formed and it is therefore called limiting reagent. This is not right, children? That also is not. Sir, but I am not able to hear the students' voice. Okay. At least I should know. No, I am not able to see the students' face also. If I see something, it's good. If they respond, it's good. Why it is not coming? Why it is not coming?
Maybe objection. Screen camera screen focus camera focus మీ ఫేస్ మొత్తం డల్ అయిపోతుంది అది విజిబుల్ కాదు అట్లా చెప్పి objection.
Otherwise, you switch off the slide, sir. But I want to see at least interacting children. How many children are there? I want to see their voice. If they're asking any doubts, I have to tell the answer.
యూజువల్ యూట్యూబ్ లో చూస్తున్నాను
Hmm.
అట్లా చెప్పి అది మాట్లాడలేదు.
Yeah, my question is if they interact, no, they're having any doubts.
నేను ఇంటరాక్ట్ అవుతాను.
Yes.
వీళ్ళు డైరెక్ట్ యూట్యూబ్ లో చూస్తారు. ఇంటరాక్ట్ కాదు.
Interact అవ్వడానికి లేదు.
మీరు మాట్లాడేది అనిపిస్తుంది. ఆ మాట్లాడేది మీకు ఇంట్రెస్ట్.
Yeah. Next one, reactions in solutions. Okay. What is this reactions in solutions? For example, okay. First of all, in chemistry, we are dealing with atoms and molecules. Already I told. Suppose how you will calculate the concentration of the solution. Suppose I went to any hotel and if I ask, I want one strong coffee, then what he will do? He will add half cup of decoction, okay, half cup of milk, and he will add little sugar and he will give. Then I will say, yes, it is a very strong coffee, yeah, my headache is gone. Okay, generally we will use this one. Otherwise, if I want the dilution, if I want one dilute coffee means he will do like this because he didn't understand that language, right? I have to ask, I want one light coffee. Light coffee means what he will do? He will add little decoction and he will add more milk. Is it right? And he will add little sugar. I will tell, yeah, this is a light coffee, this is fine. But chemistry language is entirely different. So whenever you are coming to the practicals, okay, in these practicals you have to prepare a lot of solutions. Okay, now I will ask, prepare 1 mole of oxalic acid. Okay, oxalic acid. So what is the dilution and what is the concentration? Generally, we will use concentration and dilute in chemistry language. Okay, suppose concentrated acid means what you will tell? Okay, concentrated acid means the concentration of HCl is more and you will add little water. Actually, HCl is a gas, you know, children. Hydrochloric acid is a gas, it is not a liquid. But we will pump the hydrochloric acid, the gas, in little water. Okay, continuously they will pump. So what will happen? The hydrochloric acid completely will dissolve in water. Then we will tell it is a concentrated sulfuric acid or fuming sulfuric acid or fuming HCl. You understand? Suppose I want dilute HCl. You are doing so many reactions. Add this one to dilute HCl means what you will do? You will take 10 ml of concentrated acid and you will add that solution. You will add more water. Otherwise, you will dilute this water in 1 liter of solution, right? Then you will tell it is a dilute hydrochloric acid. Concentrated hydrochloric acid means little water, you will pump more HCl gas. Okay, so concentrated and dilute word we will use in chemistry language. Okay, then how you will measure the dilute solutions? So there are different methods are there. One is mass percentage, you can calculate the dilution of solution, number one. Next one, you can use the molarity. Next one, you can use the molality. Next one, you will use mole fraction. Then you will use even normality. But normality generally in 11th standard in NCERT textbook, it is not given. Okay, but yes, entrance point of view, it is very, very important. But in practicals, I will explain what is a normality. Because in practicals, it is given normality and molarity. Okay, so first one is, see all of your textbook. Page number 19. Yeah, I will read, just check it. A majority of reactions in the laboratories are carried out in solutions. Therefore, it is important to understand as how the amount of substance is expressed when it is present in the form of the solution. The concentration of the solution or the amount of substance present in a given volume can be expressed in the following ways. That is, one is mass percent, please put tick mark children. Second one is mole fraction. Next, molality. Next one is molarity. Okay, first one is mass percent. Using mass percent, how you have to explain the dilute of solution, mass percent. How you will calculate using the dilution, that mass percent. First one, it is a mass percent of A is equal to mass of A divided by mass of solution into 100. Okay, this is a formula. How you will calculate dilute of solution using mass percent. So mass percent of A is equal to mass of A divided by mass of solution. Please underline, solution means what? Solute plus solvent. Please write down, very, very important. Solute plus solvent, both are generally we will call it as a solution into 100. Okay, one numerical problem is given in your book, in text problem, problem number 1.6, page number 19. A solution is prepared by adding 2 grams of a substance A. Means what is the weight of A? It is a 2 grams. Okay, 2 grams of a substance A to 18 grams of water. So water is what? That is solvent. It is 18 grams. Calculate the mass percent of the solute. So you have to write the formula. Mass percent of A is equal to mass of A divided by mass of solution into 100. So what is the weight of A? Mass is nothing but generally in normal language we will use a weight. So the weight of A is 2 grams divided by the mass of solution means what? Solvent plus solute. Solute is nothing but 2 grams. Means the 2 grams of compound is dissolved in 18 grams of solvent. So you have to take 2 plus 18 into 100. This is called the mass percent. So 2 divided by 20 into 100. Just to calculate 0, 0. This is nothing but right? So it is the mass percent of this compound is the 10%. Now I will ask 15 grams of, write down 10%. A solution is prepared by adding 15 grams of a substance A to 36 grams of water. Calculate the mass percent of the solute. So same thing, write down the what is the weight of A, okay, and then write down the total solution. Again you have to write the solute plus solvent both into 100. This is a simple numerical problem, but you can expect in examination this type of formula you will get half mark, and substitution you will get half mark, calculation you will get half mark, proper calculation, final answer with units, but here there is no units, generally we will write it is a 10%, okay, then final, so it is a 2 mark question children, please don't lose, write the formula, substitute properly and get the answer, right. So this is a one numerical, it is given in your book, and I have given one more problem. Next one is mole fraction. What is a mole fraction? Mole fraction definition is very, very important. Okay, I will explain what is a mole fraction. Okay, suppose same dilution, how we will calculate using solution. Already I told different methods are there. First method we completed this mass percent. Second one is mole fraction. What is a mole fraction? I will read the definition. Definition again 1 mark question important. It is the ratio of number of moles of particular component to the total number of moles of the solution. If a substance A dissolves in substance B and the number of moles are Na and Nb. Please underline children, what is Na and Nb? Na and Nb is nothing but the number of moles. Okay, suppose I have taken 1 gram of glucose, I dissolved in 1000 ml of water. Okay children, 1 gram of glucose, I have taken 1 gram of glucose and I dissolved in 1 liter of water. Then how you will calculate the mole fraction? Okay, number of moles, what is the formula of number of moles? Already you did this numericals in 9th standard. Number of moles is nothing but mass by mass of the compound divided by molar mass of the compound, or you can tell it is N is equal to weight by molecular weight. Okay children, weight, this is in the normal language we will use. Number of moles generally it is nothing but weight by molecular weight. Okay, so Na is nothing but A, for example, A is glucose. A is glucose. Okay, B is nothing but water. So A is solute and B is solvent. So solvent is more, and in this you added just 1 gram of glucose. So 1 gram is solute and 1 liter water is nothing but solvent. So how you will calculate the mole fraction of this compound? Na by Na plus Np. Na is nothing but number of moles of glucose particles. Then how you will write? Glucose is nothing but weight is 1 gram and molecular weight of glucose is what? 180. What is the formula of glucose? C6H12O6. If you calculate the molecular mass, it is a 180. Already I told how to calculate. Each carbon is 12, 1 hydrogen 1, and each oxygen atom is a what? 16. So 16 into 6, 1 into 12 and 6 into 12. If you calculate this one, you will get 180. So here weight by molecular weight, weight is 1 gram and molecular weight of glucose is 180. Right? Divided by, again Na you are calculating. Means again you write 1 gram by 180 plus NP. NP is nothing but solvent. Solvent 1 liter. Okay, suppose if you want to write in ml, you can write it in ml or you can write it in liter. But here you have to write what is the water? It is given 1 liter. What is the weight? 1 liter. But molecular weight of water is what? 18. Yes or no? H2O. H2O is nothing but 18. Each oxygen atom 16 plus 2. So it is 18. So if you calculate everything, we will write this is a mole fraction of A. And mole fraction of B is nothing but you have to write 1 liter. This is divided by 18. Otherwise, grams means you can write almost it is 1000 grams divided by 18. And here Na, same thing you have to write it. Okay? And suppose if you want to answer the final answer, suppose Xa I got some 4.2. Then what is Xp means you can calculate Xp. Otherwise Xa if you want just 1 minus Xp you will get the answer. Otherwise you write down this answer and this answer. That is your wish. Okay, this is called the mole fraction. Mole fraction is nothing but it is represented by Xa and Xp. Xa is equal to Na by Na plus Nb and Xp is equal to Nb by Na plus Nb. Okay, Na is nothing but number of moles, that is weight by molecular weight of particular compound. Okay, Nb is also generally will represent excess compound, that is water. Okay, water weight by molecular weight. Is it clear? But related numerical problems it is not given, but book bags one problem is there that we will do later. Next one is molarity. This is very important. Whenever you come to the lab, we will ask dilute this solution using molarity. Okay, molarity formula is number of molarity is nothing but they will represent it by capital M, and molarity is number of moles of solute particles dissolved by 1 liter solution. Volume of solution in liters. Okay. Sometimes they will ask what is a molarity. Molarity related numerical problems very important. It is given in book bag questions that we will do today. So molarity generally they will represent capital M. Okay, that is equal to number of moles of solute particles dissolved in volume. Generally we will measure in liters. That is volume of solution in liters. Okay, I will read this one. Molarity M, number of moles of solute particles divided by volume of solution in liters. Okay. Suppose we have 1 M solution of substance. Okay, 1 M substance of sodium hydroxide. Means 1 mole of sodium hydroxide dissolved in 1 liter of water or 1 liter of solution. Okay, 1 M means whatever the compound is there, 1 mole of particular compound is dissolved in 1 liter of solution. Is it clear, children? 1 liter. Okay. Now, related numerical problem it is given here. Calculate the molarity of sodium hydroxide in the solution prepared by dissolving its 4 grams of 4 grams in enough water to form 250 ml of the solution. So, easy way, I will tell that you can write this formula. Otherwise, one more formula is there. It is very easy to understand. Calculating the molarity. Please, this formula is very, very important. How you will calculate the molarity? See, every time in numerical problems, they will not give in liters. They will give in milliliters. Okay, so converting of milliliters to liters, if you want, you can convert. Otherwise, this is an easy way to write. That is mass by mass of the compound divided by gram molecular mass into 1000 by ml. So this is otherwise, or you can use mass is nothing but weight, and gram molecular mass is nothing but molecular weight. In simple language, if you want to write, you can write weight by molecular weight. That is nothing but m is nothing but weight by molecular weight or gram molecular mass. Anything is fine, into 1000 by ml. Now I will read this problem just to check. Calculate the molarity of sodium hydroxide in the solution prepared by dissolving its 4 grams in enough water to form 250 ml of the solution. So what is the weight of sodium hydroxide is given. M is equal to weight of sodium hydroxide is nothing but 40, right? Sorry, 4 grams. Weight of sodium hydroxide is given 4 grams. And what is the molecular weight of sodium hydroxide? Sodium hydroxide, write on one corner. Sodium is 23 and oxygen is 16 and hydrogen 1. How much? So it is 40. So this is weight. This is molecular weight of sodium hydroxide is 40 into 1000 divided by how many ml it is given? 250 ml. Okay, children, if you substitute the formula and substitute this one, it is easy to write and you will get the correct answer and you will minimize the errors, right? Then you cancel this one. Just calculate, I think roughly you will get 0.4. Yeah. 25 to 400, 40. Yeah, 40 divided by 100. Okay, so you will get 0.4 here. Yeah. And how you will write the units of molarity, that is also very, very important. Now you see the original formula, molarity is nothing but number of moles of solute particles divided by volume of solution in liters. Number of moles means here you write moles, right? Moles. And volume of solution in liters means liters. So M is nothing but moles per liter. This is a units of molarity, children, very, very important. Now the final answer you have to write, you can write 0.4 M is fine, or you can write it is a 0.4 mole per liter. Is it clear? Okay. Now same numerical problem. See page number 20, problem number 1.7. Instead of sodium hydroxide, you just take sodium hydroxide. You can take sodium carbonate Na2CO3. Na2CO3. Remaining part is same. In the solution prepared by dissolving 4 grams in enough water to form 250 ml. So same thing, but here weight by molecular weight you are writing in the case of sodium carbonate and things. This is sodium hydroxide, right? Same thing I want to do with sodium Na2CO3. Na2CO3 means 23 plus 23 plus carbon 12 and oxygen 348. If you calculate, you will get 106. So weight is 4 grams, but molecular weight here you have to write 106. Okay, and 1000 by 250. I am not changing anything. The only thing I am changing, instead of sodium hydroxide, I am taking sodium carbonate. That's all, children. Then find out the answer. You will not get 0.5. Calculate and find out the correct answer. But the units you will get dash. You will get capital M, or you will get moles per liter. Is it clear? Just write down, children, fast. Complete this numerical. Yeah. Clear? Now all of you see page number 23. One 1.11 problem, children. First one, page number 23. First one, 1.11. What is the concentration of sugar in moles per liter if 20 grams are dissolved in enough water to make the final volume up to 2 liters? Up to 2 liters. Here it is not given in milliliters. Okay. Now, same formula you write down. Molarity is equal to number of moles of solute particles dissolved, okay, in volume of solution in liters. Now, number of moles, how you will write? Number of moles is nothing but weight by molecular weight. Okay. Now, what is the weight? Capital M is equal to, what is the weight? Tell children. Weight here it is given 20 grams, right? What is the molecular weight of sugar? What is the formula of sugar? Sugar formula is given. Here it is a C12H22O11. Already I told in first class how you have to calculate the molecular mass of some compounds. In that compound I have given even sugar. Right? Sugar is nothing but each carbon atom, it is a 12. So 12 into 12. Okay, hydrogen 22, but each hydrogen weight is only 1. And oxygen it is a 16, but how many oxygen atoms? 11. If you calculate, you will get 342. So molecular weight is 342. This is nothing but number of moles. Nothing but weight by molecular weight. If you calculate 20 divided by 342, calculate very fast. What is the answer? 20 by 342. If you cancel this and this, you will get 0.0585. So directly you take capital M is equal to, that is 0. This is small n, number of moles, that is 0.0585 moles divided by volume of solution in liters, because in your book it is not given in milliliters, it is given directly liters. So just substitute 2 liters, right? If you calculate, what is the final answer, children? Calculate fast. See, roughly you will get 0.029 moles per liter or 0.029 capital M. Okay, once again I will tell. See page number 23, problem number 1.11. What is the concentration of sugar in moles per liter? Wherever you will get moles per liter, it is nothing but molarity, capital M. Okay, if it's 20 grams are dissolved, so underline 20 grams is nothing but weight dissolved in enough water to make a final volume up to 2 liters. So just substitute number of moles is nothing but weight by molecular weight of the compound. Weight already it is given in the textbook, it is a 20 grams and molecular weight of sugar is 342. If you calculate, you will get 0.0585 moles. Okay, this is nothing but number of moles. Okay, then this part will complete it. Next one is nothing but volume of solution in liters, because liters already it is given to, you just substitute and get the final answer. Here no need to use this 1000 by ml, but in this question direct liters it is given, not milliliters. So use this one. Is it clear, children? Right. Next one. Yeah, see problem number 1.6. Problem number 1.6. Problem number 1.6 and page number 22. Okay, I will read the question. Please see the textbook. Page number 22, problem number 1.6. Calculate the concentration of nitric acid. Please underline, children. Concentration of nitric acid in moles per liter. Moles per liter means what? You have to calculate the molarity, capital M. Okay. Molarity in a sample which has the density 1.41 grams per milliliter. Okay, density is given here, children. Please underline density. And the mass percent of nitric acid in it is being 69%. So here two new words. One is mass percentage here. One is it is given. Next one is density it is given. But volume it is not given. Volume it is not given. Okay, 69% it is given. See clearly. Okay, first step it is given 69%. Second one it is given what? Second step, density is given. What is the density? It is given 1.41. Okay, now how you will calculate the molarity. Okay, this is not easy problem, children. Just understand the concept first. Okay, density formula is what? Density is equal to mass by volume. This formula already you know, right? But volume you don't know. You know the density and you know the mass also. Okay, then how you will calculate? Volume is equal to mass by density. Density is given what? 1.41. What are the units it is given? 1.41 grams per milliliter. Please write the units, otherwise you will confuse. Okay, next mass is total mass you have to take. Total mass is what? Total mass it is 100%, means 69 ml of, that is a weight of HNO3. 69 grams of nitric acid is dissolved in water. So the total mass is 100. You understand? Percent means the total, everything, the total mass is 100. So mass, wherever you are getting M, it is a total mass you have to take, that is nothing but 100. Okay, children. So whenever you calculate 100 divided by 1.41, just to calculate fast. Calculate fast. Okay, if you calculate, you will get 70.92 milliliters, because this is grams will cancel and milliliters you will get. So volume now you got in milliliters. Is it clear? Children, is it clear? Right. Next, you have to calculate the molarity now. So you have to write this formula. M is equal to weight by molecular weight into 1000 divided by milliliters. Now what is the weight? HNO3 weight is what? Weight it is 69, because 69 grams of HNO3 is dissolved in water. So the weight is 69. So write down 69 is the weight. Okay. And what is the molecular weight of HNO3? Each hydrogen is 1, nitrogen is 14, and each oxygen is 16. 16 plus 3 into 3, 48. If you calculate, you will get 63, right? So 63 is a molecular weight of HNO3. Is it clear? Into 1000 divided by how many ml you are getting? Divided by 70.92. So simple one, M is equal to. Okay, I will explain once again. This problem is not very easy problem. If you do 2-3 times, then only you will understand. Okay, it is not given clearly like previous problem. What is the weight and what is the molecular weight, how many ml, it is not given clearly. So first read the problem. Here the volume is not given, but the density is given. Density formula is equal to D is equal to M by T. Okay, mass by volume. But you have to calculate the volume. So volume is equal to mass by density. So mass is nothing but they are given 69%. Okay, 69% means 69 is the weight of the compound. Okay, it is dissolved. The total mass is 100. So you have to take the total mass 100 divided by density 1.41 gram per milliliter. Please write the units. Grams you cancel, and the final answer is 100 by 1.41 is nothing but 70.92 ml. Up to this clear? Right. Second step, you have to calculate the molarity. Molarity formula is nothing but weight by molecular weight into 1000 divided by ml. So weight already you know it is a 69 grams of HNO3. So weight is 69 and molecular weight of HNO3 is nothing but you have to calculate hydrogen 1, nitrogen 14 and oxygen, okay, 16 into 3, 48. If you calculate, you will get 63. So 69 divided by 63 into formula 1000 and ml already you know 70.92. So calculate fast and find out the molarity. Fast. If you write, you will get 15.44 m or 15.44 moles per liter. Is it clear, children? Clear? Write down fast. Right. Yeah, children, now you see problem number 1.5. Okay? Alright. I will read this problem. Okay? 1.5. Calculate the mass of sodium acetate, means the weight of sodium acetate required to make 500 ml of 0.375 molar aqueous solution. So the molar mass of sodium acetate also it is given. It is given 82.0245 grams per mole. Okay? And here it is given what? So here you have to calculate what? Calculate the mass, means the weight of sodium acetate you have to calculate. Remaining part, everything it is given. 0.375 is nothing but capital M, it is molal. It is already given. Then how you will find out? So nothing but here M is equal to, okay, what is the formula? Weight by or mass by gram molecular mass, anything is fine. If you comfort, please write down mass by gram molecular weight or weight by molecular weight. Anything is fine. Molecular weight into 1000 by ml. Okay, children? M is equal to. But M it is given what? 0. How many it is given? 0.375. Okay, but weight you don't know. Weight you have to calculate or mass you have to calculate. And molecular mass of sodium acetate is given. What is the molecular mass of sodium acetate is given? 82.02. You can take 82. Otherwise you can take 82. That's fine. If you want 0 to also include. Okay, into 1000 by ml. How many ml it is given? 500 ml. Just simple calculate weight. Okay, please see this numerical problem. In this numerical problem, first write down the formula. Mass, molarity is equal to weight by molecular weight into 1000 by ml. But here, you know 1000 and ml it is given 500. This 2 you can substitute. And here molecular weight of sodium acetate it is given 82.02. But molarity also it is given 0.375. And for your duty is you have to find out only the weight. So weight is equal to just multiply and write the answer. Is it clear, children? Do it fast. Right. Now you have any little idea, right? What is molarity and how you have to do few numerical problems using molarity, right? We completed nearly book back questions. 1.11 we completed, 1.15 we completed, 1.16 we completed, right? Yeah. Now see 1.4 all of you. 1.4. I will read the question, but already first part I completed this stoichiometric calculation, right? Calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. So write the equation, how you will get the carbon dioxide? Carbon plus oxygen gives the carbon dioxide, right? Otherwise, number of moles means how you will explain? 1 mole of carbon is reacting with 1 mole of oxygen and you will get 1 mole of carbon dioxide. Suppose I want to calculate in grams, then 12 grams of carbon is reacting with 30 because each oxygen atom is 16. So 16 plus 16, 32. 32 grams of oxygen and you are getting how many grams of carbon dioxide? 44 grams of carbon dioxide. This is also homework for you. Simple one, okay? You have to calculate 1 mole of carbon is burnt in air. So write the formula. Second one, 1 mole of carbon is burnt in 16 grams of oxygen. 1 mole, listen, suppose 1 mole of carbon is reacting only with 16 grams, then what you will get? Next one, 2 moles of carbon burnt with 16 grams of dioxygen. So simple numerical problem. Tomorrow definitely I will ask this question. Okay, do it and tomorrow you have to tell this answer. Okay, problem number, this is nothing but problem number 1.4. Right. Next one, calculate the mass percent of different elements present in sodium sulfate, Na2SO4. This is also previous class I have taken what formula you have to use, but here you have to calculate the sodium separately, sulfur separately and oxygen separately. This is also homework for you children. Problem number 1.2. Okay. So what is the formula first you tell? How you will write this formula? Mass percent is nothing but mass of the element divided by molecular mass of the compound into 100. Just substitute one. Each one sodium alone you separate. Okay. 2 into sodium sulfate formula. Total molecular mass you write down. And each sodium atom 23. So here 2 sodium atoms are there. 2 into 23 divided by total mass of Na2SO4 into 100. Okay, like that again sulfur, again oxygen you calculate, and I want the 3 separate mass percent. One is sodium, one is sulfur and one is oxygen. That you find out. And 1.3 also last class I have given homework. Okay, determine the empirical formula of the oxide iron which has 69.9% of iron and 30.1 dioxygen by mass. The formula is nothing but Fe2O3. Just substitute that one. All the categories I have given. The final answer is Fe2O3. Okay. Same problem in even 1.8 also it is repeated. There is no much difference. Here also same problem it is repeated. Again Fe2O3 only the final answer. Right. Yeah, see 1.10. This is also like a stoichiometric calculation. The 3 moles of ethane, that is C2H6, calculate the following. Okay, 3 moles of ethane. How you will write 3 moles of ethane? Moles of ethane. This is a final product. Otherwise, if you want, you can write even reactants. It is how many? 6 carbon atom because carbon is a monoatomic, right? And hydrogen is a diatomic. So you have to take 9 H2. Means here also 18. Okay. Now, first one. In 3 moles of ethane, calculate the following. First one is number of moles of carbon atoms. How many number of moles of carbon atoms are there? 6 or 3 to 6. Okay, first one is 6 answer. Second one, number of moles of hydrogen atoms. It is not given molecules. Atoms it is given, it is a 18. Right? Yeah, next one, number of molecules of ethane. Number of molecules of ethane. So generally we will write it is a 3 molecules, but you have to take even in Avogadro number. Okay. So it is nothing but 3 into Avogadro number. 3 molecules. Okay. 1 molecule is nothing but 1 molecule is 1 Avogadro number, right? 6.022 into 10 to the power of 23. 1 molecule of ethane. Suppose if you take 3 molecules of ethane, how many Avogadro number is 3 into 6.022 into 10 to the power of 23. So 18.88 into 10 to the power of 23. Please write on that. Yeah. Even see page number 20, molarity it is given, calculation part, M1 V1 is equal to M2 V2. Even you can calculate M1 V1 is equal to M2 V2. Related these numerical problems, what is M1, what is V1, M2 and V2, I will take this class tomorrow because it is completely related to your practical thing. Okay, sometimes they will ask initial molarity, next final molarity, initial volume and final volume. Related numerical problems we will do later. Okay. And I have to complete this limiting reagent problems. So next class, I will complete this limiting reagent problems and molarity. Using M1 V1 is equal to M2 V2 related problems I have to complete, and next I have to complete even molality. Okay, what is molality and how you will interrelate molarity and molality. Okay, that is also important. One numerical only is given your in-text question that we will do, and just I'm having few more minutes. Just I will start what is molality. Molality. Molality generally they represent with a small m. Okay, molarity RITY, that is RITY generally we will represent capital M. Okay, its unit is moles per liter. Okay, but molality LITY, this is generally we will represent small m. Okay, small m is nothing but again same number of moles of solute particles dissolved in 1 kilogram of solvent. 1 kg of solvent, very important children. Even sometimes, actually this year 12th standard board exam, they ask what define molality. Define molality, they ask 12th standard board exam. So please write down, most of the students they will confuse and they will write molarity formula. They will write number of moles of solute particles is same in the case of molarity and molarity. There is no doubt. But down here it is a 1 kg of solvent. Solvent alone. Please underline. Solvent. It is not solution. Okay. Only pure solvent. You should not take solute particles. But in the case of molarity, it is given volume of solution in liters. Okay, but here 1 kg of solvent. Okay, but here molarity, we will use solid 1 kg of solvent, but there we will use volume. Volume is what? Temperature dependent. Yes or no? If I increase the temperature or I decrease the temperature, the volume will change. Yes or no? But if I increase the temperature and decrease the temperature, is there any change in this solvent? Because it is a solid. Okay, related theory part, it is important. Just I will tell the page number. Yeah. See page number 21. Page number 21, last one, this problem number 1.8, it is given. Problem number 1.8, last 21. See the last 4 lines. Note that molality of a solution does not change with temperature since mass remains unaffected with the temperature. Whereas molarity will change with the temperature because it is a volume dependent. This type of thing, even 12th standard board exam, you will get this reasoning question. Okay, molality is not temperature dependent because it is a solid, but molarity is a temperature dependent because it is represented the volume. Okay, thank you, children.
Online class or recorded class?
It is recorded.
Recorded. Teaching to watch.
Good morning, my dears. So welcome to the physics session. Let us start. Let us continue the kinematics. On Saturday we have started learning kinematics. Let us continue today. Sorry, my dears. Welcome to the session. As we are learning about kinematics in the last class, we learned up to different types of aspects. Let us recap all the terms, the concepts which we have come across in the concept of kinematics. Once again, we have started learning kinematics with the rest and motion. We know that when a body does not change its position continuously by time with respect to a frame of reference, then the body is said to be at rest. Similarly, motion. When a body changes its position continuously by time with respect to a frame of reference, then the body is said to be in motion. What is the frame of reference here? The frame of reference is just the background from which the observations are made. Then, whether rest and motion are relative or absolute. So, with an example, we have come that rest and motion is relative. Okay, then to study motion more clearly, one should know about the path along which the body has moved. What do you mean by path? A path is just a line segment which joins the 2 points. Okay. So based on the path, motion is again classified into 3. That is one-dimensional motion, where only one coordinate axis is considered, that is x-axis. 2-dimensional motion, where 2 coordinate axes are considered, that is x, y. And 3-dimensional motion, where 3 coordinate axes are considered, that is x, y, and z axis. Okay. Now, again, whether path is relative or absolute? The answer is yes, path is relative. So, why path is relative? For 2 different observers, the observations are different. When the observations are different, no doubt it will fall into relative, true observations. That's why path is a relative. To understand motion more clearly, we learned about 2 more terms. One is distance, another one is displacement. Okay, what do you mean by distance traveled by the body? The actual length of the path traveled by the body, irrespective of its direction, is called the distance traveled by the body. In the definition itself, it is very clear that the direction is not at all considered for a body moving in different directions. That is distance traveled. And what is displacement? The shortest length of the path traveled by the body from initial position to final position. This is called displacement. Distance is a scalar quantity. Displacement is a vector quantity. Because distance has no direction, displacement has direction. Then, either distance or displacement, both are measured in centimeters, meters, or in kilometers. Okay. Then coming to the notes, distance and displacement will be same when a body travels in a single straight line. Next, distance can never be 0. Distance can never be negative. Distance will be always positive. Why? The total length of the path traveled by the body is called distance. Therefore, irrespective of the direction, whatever the path traveled by the body, all these paths are summed up. Therefore, we will get the distance. While coming to the displacement, it is the shortest length of the path traveled by the body from initial position to final position. Displacement can be 0, displacement can be negative, displacement can be positive. So we have come across why displacement is positive, negative, and zero in the last session. After distance and displacement, we have come across two more terms, that is, one is speed and the one is velocity. Again, speed is a rate of distance traveled by the body is called speed. So, speed is equal to distance by time. I will write it. Speed is equal to V is equal to distance by time. So, speed is denoted by V. S is the distance traveled by the body and T is the time taken. Then, speed is measured in centimeter per second or meter per second or in kilometer per hour. This can also be written as km h inverse kilometer per hour. Okay, so by seeing this formula, you can clearly say that speed is a scalar quantity. Why it is a scalar quantity? As distance is a scalar quantity, as distance is not dependent upon the direction, therefore distance is a scalar quantity. Speed is a measure of distance by time, therefore speed is also a scalar. Okay. Then we have come across different types of speed. How many types of speeds are there? There are three types of speed. The first one is uniform speed. Uniform speed. Second one is variable speed. And the third one is average speed. And the fourth one is instantaneous speed. See, I have mentioned that only three types of speeds are there, but I have listed four. See, the actual term speed does not exist. The actual terminology of speed is average speed. We have the term called average speed, but not just a speed. Okay, so that's why I've just included average speed, but actual types of speeds are uniform, variable, or non-uniform, or instantaneous. What is a uniform speed? A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time, however small the time interval may be. Right? Next, variable speed. A body is said to be moving with variable speed if it covers equal distances in unequal intervals of time or unequal distances in equal intervals of time. Next, instantaneous speed. Speed of a body at any particular instant of time is called instantaneous speed. See, if you remember in the last class, I have given a formula how to mention an instantaneous speed. Okay. So instantaneous speed, V instant is equal to limit delta t tends to 0, delta s by delta t. See, you are not aware of limit. This is LT. LT means limit. Delta t tends to 0. Delta s by delta t. Delta means change. Change, a small change. Why a limit is applied? A limit is applied when we are unable to compare the time interval. That's why limit delta t tends to 0. See, for example, the distance traveled by the body lies between 0 to 1 second. See, we are not mentioning that the distance traveled by the body is 1 second or 0. We are unable to mention. Okay. In this situation, if the time interval lies between 0 to 1, that is 0 is the lower limit, 1 is the upper limit, such formula has to be used. Whenever limit delta t tends to 0 is applied, now the formula would become V instantaneous is equal to ds by dt. What is d here? D is called as derivative. Derivative of speed with respect to the time interval. This is the formula for the instantaneous speed. Then, now let us touch the average speed. What do you mean by average speed here? A body traveling with the variable speed, keep it in your mind, a body traveling with the variable speed, then the average speed is the ratio of the total distance traveled to the total time taken. Okay, total distance by total time taken. This is the actual formula. But in the starting, I mentioned it as a speed. Okay, so for your clear understanding, so my dears, speed does not exist. Average speed, the existence is average speed. But for our convenience, we are terming it as a speed. But actual terminology is average speed. So average speed, we average total distance by total time taken. Understood? This is how the speed is learned in the last class, still speed. Okay, now stepping ahead with the velocity. Yeah, coming to velocity. What do you mean by velocity? The rate of displacement is called velocity. The rate of displacement. Velocity is equal to displacement by time. As the speed is distance traveled by time and velocity is displacement by time. So how to represent? V bar is equal to S bar by T. Okay, but I mentioned when we are learning speed, I have clearly mentioned that a speed and velocity, the terms speed and velocity, they are not the actual terms. They should be termed as average speed, average velocity, isn't it? So therefore, average, I am adding average. Velocity just simply use, but average velocity is the actual terminology. So average velocity is equal to total distance by total time taken. Therefore, V bar is equal to S bar by T. What is velocity? It is a vector physical quantity. Why it is a vector physical quantity? Because the displacement is a vector, so velocity will be a vector. Then how do you measure velocity? Velocity is measured same as speed. That is centimeter per second, meter per second, or in kilometer per hour. Okay, centimeter per second is the least value, kilometer per hour is the highest value. Same as speed, let us learn about different types of velocities. What are the different types of velocities? So again, there are three types of velocities. One is uniform velocity. Uniform velocity. What do you mean by uniform velocity? A body is said to be moving with uniform velocity if it covers equal displacement in equal intervals of time, however small the time interval may be. Okay, I'll repeat once again. A body is moving with uniform velocity if it covers equal displacement in equal intervals of time, however small the time interval may be. And what is the second one? Variable velocity. Variable velocity is also known as non-uniform velocity. What do you mean by variable velocity here? When a body is said to be moving with variable velocity if it covers equal displacements in unequal intervals of time or unequal displacements in equal intervals of time. Understood? See, there is no difference in terming all these things with respect to speed and velocity. Both are same, but speed has no direction, velocity has direction. That's all. Okay? Once again, a body is said to be moving with variable speed or in non-uniform velocity if it covers equal displacement in unequal intervals of time or unequal displacements in equal intervals of time. Right? Then how to define average velocity? See, average velocity will be next to the variable velocity. Okay, so what is average velocity? A body moving with variable velocity, then average velocity is a ratio of total displacement to the total time taken. Okay, total displacement by total time taken. So we have come across all these things. What is the next one? Instantaneous velocity. Instantaneous velocity. What do you mean by instantaneous velocity? Same. A body is said to be moving with instantaneous velocity. Instantaneous velocity. Okay, that is velocity of a body at any particular instant of time. Velocity of a body at any particular instant of time is called its instantaneous velocity. See, for example, when your friend is driving a car or riding a bike, if you call at that particular time and if you ask what is the speed at this moment, okay, he immediately looks into the speedometer, and he says that yes, my speed is 70 kilometers per hour at this position. That is called instantaneous speed. Okay, speed at a particular instant thing, instantaneous. Okay, so same as instantaneous speed, v bar instantaneous is equal to limit delta t tends to 0 delta s bar by delta t. Now it would be v instantaneous is equal to ds bar by dt. This is the formula for instantaneous velocity. Understood? There is no difference between terming a speed and velocity. Just speed is a scalar quantity, velocity is a vector quantity. Okay? So for a vector, always there will be a representation that is arrow mark over its head. So that is the easy, understandable concept. Understood? Right. So same as speed, different types of speed we learn: uniform speed, uniform velocity, non-uniform speed or variable speed, variable velocity, non-uniform velocity, then instantaneous speed, instantaneous velocity. So again, they are measured in the same way. Either speed or velocity, both are measured in centimeter per second, the least value. Meter per second, the moderate value, kilometer per hour, the higher value. Okay. So, based on speed and velocity, let us now solve few numericals based on this. Okay. So now kindly take the question. Write down. A car covers first half of the distance with the speed v1 and the second half of the distance with the speed v2. See, the second half of the distance means the remaining half of the distance with the speed v2. Calculate its average speed. That is the question. See, in the given question, the total distance was split into two equal halves. Let us draw A, B, the length of the path, S be the total distance. Okay. This total distance was split into two equal halves. Two equal halves. That is S by 2 and S by 2 respectively. What is mentioned in the question? The first half of the distance with the speed v1 and the remaining half of the distance with the speed v2. Find the average speed. Let us find the average speed. What is the formula for average speed? V average is equal to total distance by total time. Okay. First, we require time taken. Time is not mentioned. Speeds are given. Distances are given. Time is not mentioned. Let us find the time first. Let T1 be the time taken for the first half distance and T2 be the time taken for the second half distance. Okay. Then total time T is equal to T1 plus T2. Following. Now, let us write separately what is T1. Time is equal to distance by velocity. That is S by 2v1. Similarly, T2 is equal to S by 2v2. Now let us substitute here. Capital T is equal to S by T 2v1 plus S by 2v2. Now what will be the LCM here? LCM will be 2v1 and v2. Now let us take LCM. 2v1, v2 is the LCM. Then here it will be v2s plus v1s. 2v1 will go, v2 will be left over. 2v2 will go, v1 will be left over. Okay. Now t is equal to, I can take s common here. S into v1 plus v2 by 2v1 v2. Now I got the total time. So now I am in a position to substitute the time interval and solve the remaining thing. V average is equal to total distance is yes, no doubt. And what is the total time? S into v1 plus v2 by 2v1 v2. Just now we solved the total time. Now see, S can be cancelled. Therefore, V average is equal to 2v1 v2 by v1 plus v2. This is the answer. Understood clearly? See what we did here? Distance and the speed are mentioned, okay, in the problem. Time is not mentioned, but we know the average speed formula. Average speed is equal to total distance by total time. We don't know the time, so that's why we assume that T1 be the time taken by the body for the first half distance, T2 be the time taken for the second half distance. Solving T1 and T2, we got the total time taken. that we substituted the actual formula and got the result as V average is equal to 2V1 V2 by V1 plus V2. Understood? Clearly? Very good. Now, I'm going to give a similar problem. Okay? No difficulty at all. Similar problem. Now take the question. A car covers 1/3 of its distance with the speed V1. The second 1/3 of the distance with the speed V2. And the last 1/3 of the distance with the speed V3. Find its average speed. Okay? I think the question is absolutely clear. It is similar to the question which you did just now. Let me repeat the question. A car covers 1/3 of the distance with the speed V1. The second 1/3 of the distance with the speed V2. And the remaining, that is the last 1/3 of the distance with the speed V3. Find the average speed. Okay, let us find. As usual, first we draw the diagram. AB is the length of the path. The total distance is S. Okay. Now split the total distance into 3 segments. One is S by 3, S by 3, and S by 3 respectively. Why? First 1/3 distance, second 1/3 distance, and the last 1/3 distance. With the speed V1 the first, V2 the second, V3 the last 1/3. Okay, as usual, we need to find the time interval. What is the time taken for the first 1/3? T1. Second 1/3? T2. Third 1/3? T3. Okay. So to calculate the average speed, what is required? Total distance by total time. We know that total distance is S, but we don't know the total time. Let us find the total time. Total time T is equal to T1 plus T2 plus T3. Okay. See, I'm going to write the T1, T2, T3 for your convenience here. What is T1? S by 3 V1. T2 S by 3 V2. T3 S by 3 V3. Now substitute the values here. T is equal to S by 3 V1 plus S by 3 V2 plus S by 3 V3. Now what will be the LCM here? The LCM will be 3 V1 V2 V3. Now coming to the first 3 V1, what is left over? S into V2 V3 plus S into V1 V3 plus S into V1 V2. Understood? Now we got total time. Our total time is equal to S can be taken common here. S into V1 V2 plus V2 V3 plus V1 V3 by 3 V1 V2 V3. This is the time. Now you know total distance and total time. Now substitute in the formula. V average is equal to total distance is S and the total time is S into V1 V2 plus V2 V3 plus V1 V3 by 3 V1 V2 V3. As usual, distance can get cancelled. Now average speed, therefore average speed is equal to 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V1 V3. This is the formula. The general mistake which you do in this type of problems is taking the LCM in an improper way. Okay, generally, most of you people will not come out with this result. You may say that, sir, 3v1, v2, v3 by v1 plus v2 plus v3. Okay, that is wrong. If you are very good at taking LCM, then the result will come out in a proper way. Understood? This is how the problem can be solved. Now I am going to give a numeric based on values. I'll give the numerical values. Try to substitute and find out. Okay? Now take the question. A cyclist moving on a circular track. A cyclist moving on a circular track of radius 100 meters. He covers one revolution in 4 minutes. He covers one revolution in 4 minutes. Find his average speed and average velocity. See, as long as physics concerned, try to draw the diagram to the given question. Half of the work will be done. Understood? Don't try to solve the numerical in a conceptual way. First, you should analyze what is given. Mention the same onto the paper in the form of diagram. Okay? This is a circular track whose radius is 100 meters. Okay? What is given? One revolution. He makes one revolution in 4 minutes. One revolution in 4 minutes. Now we need to calculate distance, V, displacement. Okay. See, clearly displacement is equal to 0. It is very easy, isn't it? We need not to calculate. Directly we can say displacement is, displacement is equal to 0. Understood? So, by displacement is equal to 0, the displacement is equal to 0 because the starting point and the ending point of the body are same. When starting point and ending point are same, then there is no displacement made by the body. Understood? And what is the distance traveled by the body? The distance traveled by the body is equal to its circumference, which is 2 pi r. Okay? That is equal to 2 pi into radius 100. Okay? Then distance is equal to 200 pi meters. Here, pi you can take it as 22 by 7 or 3.14. Understood? Okay. Now, distance we found out. Displacement we know it is 0. Now, average speed and average velocity. So, average speed. V average is equal to total distance by total time. That is equal to total distance 200 pi by what is the time? In 4 minutes. 4 into 60 seconds. Okay. So, meter per second. And what is average velocity? V average is equal to total displacement by total time. Therefore, average velocity is equal to 0 because displacement is equal to 0. Okay, so you can calculate this part, right? This is 0 and 0 gets cancelled 5 times. 5 by 6 pi meter per second. Okay, so as I said, pi can be taken as 3.14 or 22 by 7. This is the answer. This is average velocity and this is average speed. Understood? Shall we go to the next problem? Right. Take down. A car covers the first half of the distance between two places with a speed 40 kilometers per hour. Once again, a car covers the first half of the distance between two places with a speed 40 kilometers per hour. And the second half at 60 kilometers per hour. What is the average speed of the car? Okay, the question is very clear. First of all, take the diagram directly. What is given in the problem? A and B are the two places. Okay. The first half between two places in 40 kilometer per hour. The remaining is 60 kilometer per hour. This is what given in the problem, isn't it? So I think by seeing this problem, you can clearly get an idea how to solve this problem. Only speeds are given, distance is not given. But we have done a practice problem based on the same concept, isn't it? So what you got the answer as average speed is equal to 2v1 v2 by v1 plus v2. Understood? Use the same. That is equal to 2 into 40 into 60 by 40 plus 60, which is equal to 2 into 40 into 60 by 100. 0 gets cancelled. So average speed is equal to 2 into 4, 8, 8, 6, 48 kilometer per hour. This is average speed. Understood how simple it is, right? So shall I give one more problem? Right, take it down. A train moves with a speed of 30 kilometers per hour. A train moves with a speed of 30 kilometers per hour in the first 15 minutes with another speed of 40 kilometers per hour the next 15 minutes and then with a speed of 60 kilometers per hour the last 30 minutes. Calculate the average speed of the train for this journey. Okay, simple again. What is given? Again, draw the diagram. A to B. Divide into 2. This is 30 minutes. Again, this 30 minutes is divided into again 2. First 15 minutes with 40. First 15 minutes with 30. The second 15 minutes with 40. 30 kmph. The second 15 minutes with 40 kmph. Okay. And the last 30 minutes with 60 kmph. So if you able to draw the diagram, half of the numerical is said to be done. So what you have to calculate here? We need to calculate the distance traveled in the first 15 minutes, distance traveled in the second 15 minutes, and the distance traveled in the last 30 minutes. Work is said to be done. Why? Average speed is equal to total distance by total time taken. That is, average speed is equal to total distance by total time taken. Okay? How to calculate total distance? Total distance. S is equal to S1 plus S2 plus S3. Okay? Distance traveled in first 15 minutes is equal to V1 into T1. That is, what is V1? 30 kmph into time 15 minutes. What do you mean by 15 minutes? We can write it as 1 by 4 R. Okay. Next, distance traveled in next to 15 minutes. That is V2 into T2. Again, 40 kmph into 1 by 4 R. And the next one, distance traveled in the last 30 minutes, V3 into T3, that is 60 kmph into 1 by 2 R, half an hour. Shall we solve here? 1 by 4, 10, distance is equal to 10 kilometers here, and the distance is equal to 430. How many times? 4. 4 6 are 24. 4 7 are 28. 7.5 kilometers, and here it is 30 kilometers. For the first 15 minutes, the distance traveled is 7.5 kilometers, second 10 kilometers, and third 30 kilometers. What is the total distance? S is equal to 7.5 plus 10 plus 30. Then S is equal to 47.5 kilometers. What he has to calculate? He has to calculate the average speed of the train for this journey. Average speed. Now coming to the average speed, V average is equal to total distance by total time. What is the total time here? Total time T is equal to T1 plus T2 plus T3. That is 15 minutes plus 30 minutes, which is equal to 1 hour. Time is 1 hour here. Okay. Then average speed is equal to 47.5 by 1, which is equal to 47.5 kilometers per hour. This is how it to be calculated. Understood? Look into the solution procedure. 3 different speeds and time is mentioned, but distance is not mentioned here. First distance, with a speed of 30 in a time interval of 15 minutes. The second distance with a speed of 40 in 15 minutes. And the last distance with a speed of 60 in 30 minutes. Yes, we know average speed is equal to total distance by total time. As we are not aware of distance because distance is mentioned, only speeds and time is mentioned. So based on speeds and time, we have calculated the distance traveled in the first one third or in first 15 minutes, distance traveled in second 15 minutes, and the distance traveled in the last half an hour, that is 30 minutes. So we got S1, S2 and S3 substituted, we got the total distance as 47.5 kilometers. Then average speed, total distance by total time, then total distance is 47.5 kilometers and the duration of 1 hour. Obviously, average speed will be 47.5 kilometers per hour. Understood? Shall we step into another concept? So I think now you can solve the numericals very easily. Okay, now I'm going to give a small list, that is flow chart, where we started and what are we started. See, our major concept is motion. Okay, to learn motion more clearly, distance and distances are introduced, distance and displacements. Okay, from distance we learn speed, displacement, velocity. Okay, we learn different types of speeds, different types of velocities. Now, and we solved few problems based on speed and velocity also. Based on speed and velocity, we have acceleration. Acceleration. Okay. Acceleration is also a term which makes us the motion to understand more clearly. What is acceleration? The rate of change of velocity is said to be acceleration, isn't it? The rate of change of velocity is called acceleration. So, acceleration is equal to change of velocity by time. Change of velocity by time. So, acceleration A bar is equal to delta V bar by delta T. Acceleration is a vector physical quantity. This acceleration can also be written as A bar is equal to V bar minus U bar by T2 minus T1. Final velocity, initial velocity by change in velocity. Okay. Then how acceleration is measured? Acceleration is measured in centimeter per second square, meter per second square, kilometer per hour square. See, generally, kilometer per hour square is not used. Okay, so as from the distance, we have been using three different measurements. That's why here also I mentioned the higher measurement of acceleration also. But the most convenient way of expressing acceleration, the measurements of acceleration is centimeter per second square or meter per second square. Understood clearly? Okay, the rate of change of velocity is called acceleration. Therefore, change in velocity I represent as delta V bar by delta T. As velocity is a vector quantity, acceleration is also a vector quantity. Or acceleration can also be represented as a bar is equal to v bar minus u bar by t2 minus t1. V bar minus u bar represents change in velocity. Similarly, time interval, change in time interval also. This is acceleration. See, as we learned about different types of speeds and different types of velocities, do they exist in acceleration also? That means, are there different types of accelerations? Yes, no doubt. There are again different types of acceleration. What is the first one? Uniform acceleration. How do you mention the uniform acceleration? If the change in velocities, uniform acceleration can be defined as the change in velocity by equal amounts in equal intervals of time. Okay? Change of velocity in equal amounts in equal intervals of time. However, the time small interval may be. This is called uniform acceleration. And what is the next one? Variable acceleration. What do you mean by variable acceleration? If the acceleration of a body is said to be variable acceleration, if the change of velocity takes place by unequal intervals of time, change of velocities by unequal intervals of time is called as a variable acceleration. That is non-uniform acceleration. And next one, instantaneous acceleration. As we define speed and velocity, that is speed of a body at a particular instant of time, or at any particular instant of time, velocity of a body at any particular instant of time. Similarly, acceleration, instantaneous acceleration. Acceleration of a body at any particular instant is called instantaneous acceleration. Same for instantaneous acceleration, I'm mentioning here, a bar instantaneous is equal to limit delta t tends to 0, delta v bar by delta t. Therefore, a bar instantaneous is equal to dv bar by dt. Okay, I think it is not visible. dv bar by dt. This is instantaneous. Understood? So these are the different types of accelerations. Apart from different types of accelerations, we have two more types of accelerations. What are the two more types of accelerations? One is positive acceleration, and the second one is negative acceleration. See, there is no other term for positive acceleration, but negative acceleration can also be called as deceleration or retardation. Understood? Negative acceleration can also be called as deceleration or retardation. So what is the difference between the positive acceleration and the negative acceleration? That is deceleration. See, when a body is moving towards positive x-axis, okay, when the velocity of the body is increased in the same direction, then the body is said to be moving with positive acceleration. Okay, when the velocity of the body is increased, understood, in the same direction, then the acceleration of the body is said to be positive acceleration. Similarly, when the velocity of the body decreases, when would the velocity of the body decreases? When? By applying the brakes. Okay, if you want to reduce the speed of the vehicle, obviously we need to apply the brakes. So the velocity of the body, the change of velocity of the body in the negative x-axis is called as negative acceleration or deceleration or retardation. A very good example for deceleration or retardation. Throw a body up into the air. When a body is thrown up into the air, we can say that the body is said to be moving with deceleration. Why? The velocity, when a body is moving in upward direction, the velocity of the body goes on and decreases. Finally, a point is reached by the body where its velocity is equal to 0. Understood? Okay, the point where velocity is equal to 0. That means why the velocity becoming 0? Because from the point of projection, the body is moving upward with a negative velocity. I mean to say decreasing velocity. Why? Under the influence of gravity on the body. This is called as deceleration, or also called as an retardation. Understood? So this is about acceleration completely. So let us do few numericals based on acceleration. See, most of the acceleration part depends upon calculus method. This calculus method we will do when you start coming to school from June onwards. So because if I start teaching the calculus here, you will not understand properly. Okay, so the calculus part I will start only when you come back to the school from June 1st onwards. Let me take you to the continuous concept of kinematics, that is equation of motion. See, up to here, this gives the complete knowledge of motion. Complete knowledge of motion. Motion, the introduction. To know motion more clearly, distance, displacement. From distance and displacement, speed and velocity. Again, from speed and velocity, the concept of acceleration. Okay, this is how the branch starts. Now, the motion is very, very clear for us. Understood? Now, I will take you to equations of motions. See, I think the equations of motions are introduced in class 9, right? Okay. How many equations of motions are there? Any idea about it? Yes, there are 3 equations of motions. Okay, 3 equations of motions or 4 equations of motions? 3 or 4? Let us see. There are mainly 3 equations of motions. What is the first equation of motion? The first equation of motion is V is equal to U plus AP. This is the first equation of motion. Okay, let us learn about the first equation of motion, how it can be derived. Now draw A to B. Let S be the distance from A to B. It takes a time t seconds to travel. Let U be the initial velocity and V be the final velocity. Now, the body is said to be traveling with uniform acceleration. Okay, I've listed all the parameters with what the body possesses at the time of its motion. Let us see the diagram once again. Body starts its motion at A with an initial velocity u meter per second, travels a distance of s kilometer in a time t seconds with an uniform acceleration a meter per second square, ends its journey with the final velocity v meter per second. Understood? Following. See, all these equations of motions will be based on uniform acceleration only. Understood? Now, see, we know that acceleration a bar is equal to v bar minus u bar by t. Just now we learned acceleration is equal to change of velocity by time interval. And moreover, V is equal to U plus AT is the only equation which represents a vector. The other quantities will not represent a vector. Okay. Now, let us cross multiply it. AT is equal to V minus U. Right. Now, V bar is equal to U bar plus A bar into D. This is how the first equation of motion is obtained. Understood? Shall I repeat? Look carefully. The body starts its journey at A with an initial velocity u meter per second, covering a distance of s kilometers within a time t seconds with the uniform acceleration a meter per second square, ends its journey at B with a speed v meter per second. Okay? As we know that acceleration, a body is said to be moving with uniform acceleration. Then, straight away, take the formula of acceleration. You can get the derivation for the final velocity. A bar is equal to V bar minus U bar by D. Cross multiply. A bar into D is equal to V bar minus U bar, or V bar is equal to U bar plus A bar into D. Okay, so in this equation, all are represented to vector. Therefore, this equation represents a vector. Okay. Then the second equation, S is equal to ut plus half at square is the second equation. Okay. Now let us solve the second equation of motion. To solve the second equation of motion, same parameters are considered. Same parameters, no doubt. A body traveling with initial velocity covers a distance of s kilometers within a time of t seconds and moving with the uniform acceleration a meter per second square. And it ends with the final velocity v meter per second. All the parameters are same. We are not at all going to disturb, right? To solve the second equation, the second equation is based on displacement. What is the displacement made by the body? See, we know that distance traveled, s is equal to average speed into time, distance or displacement. When a body is moving in a single straight line, distance traveled by the body is equal to its displacement, right? Okay. Distance is equal to average speed into time. Then average speed can be written as v plus u by 2 into t, or u plus v. Okay, I will write it as u plus v into t. But by seeing v, just now we derived it is u plus at. We can now s is equal to u plus at by 2 into t. Now u plus u, 2u plus at by 2 into t. Now multiply with the t. S is equal to 2ut plus at square by 2. Now you can split this expression as S is equal to 2ut by 2 plus at by 2, at square by 2. Again, if you take the LCM, you will get the same expression. Now see, gets cancelled. Therefore, S is equal to ut plus half at square. This is second equation of motion. Okay, understood? Just see once again how we started this second derivation. We started with distance. Distance traveled is equal to average speed into time. Average speed can be written as u plus v by 2. In the place of v, we took v is equal to u plus at that we used there, and 2u plus at by 2 into t. Now multiply with the t, 2ut plus at square by 2. Now split the expression, 2ut by 2 plus at square by 2. 2 gets cancelled. And the final expression for the distance or displacement, S is equal to ut plus half at square. Understood? Okay. So under the same derivation, that is s is equal to ut plus half ac square, we have one more equation, that is essence formula. Distance traveled in nth second is equal to u plus a into n minus 1 by 2. Okay. How to obtain this equation? Distance traveled in nth second is equal to distance traveled in n seconds minus distance traveled in n minus 1 second. Understood? Distance traveled in the nth second. That means, what is the distance traveled by the body in the first second, second second, fourth second? Okay, what do you mean by this? See, what is the distance traveled by the body in the fourth second? That means a completion of 3 seconds. Understood? Starting of the fourth second, end of third second. That is the meaning of fourth second. Understood? How to solve distance traveled in n seconds minus distance traveled in n minus 1 second. So, distance traveled in n second, I can write it as un plus half an square. Okay? Minus u into n minus 1 plus half a into n minus 1 whole square. Okay. What change you observed here? Simple. T is replaced by n. That's all. Now, un plus half an square minus un minus 1, sorry, minus u into n minus u into 1 plus half a into a minus b whole square, n square plus 1 minus 2n. Okay, next. un plus half an square minus of un minus u plus multiply with the half an square plus half a minus half a into 2n. See, I did not multiply with minus yet. 2 gets cancelled. Now, un plus half an square. Now I am going to multiply with minus. Minus un plus u minus half an square minus half a plus an. Minus into un, minus into minus plus u, minus into minus, minus half an square, minus into plus, minus half a, minus into minus, plus an, right? Now, plus un, minus un, half an square, minus half an square. What are left over? I'll mention here. Distance traveled in nth second is equal to what are left over? U plus an minus half a. These are left over. U, an minus half a. Now see, distance traveled in nth second is equal to u plus a can be taken common, a into n minus 1 by 2. This is the formula for the distance traveled in nth second. Okay, look into the derivation clearly. Okay, shall I explain once again? Distance traveled in nth second is equal to distance traveled in n seconds minus distance traveled in n minus 1 second. Distance traveled in nth second, I wrote it as un plus half an square minus of u into n minus 1 plus half a into n minus 1 whole square, expanding, solving. The final result is Sn is equal to u plus a into n minus 1 by 2. Understood? Okay. Stepping into the third expression. What is the third one? The third equation of motion is v square minus u square is equal to 2as. V square minus u square is equal to 2as. Okay. Now how to obtain this equation? See, from equation 1, v is equal to u plus at. Okay. Now, rearranging, we get v minus u is equal to a. This we will write it as equation a. Okay. Next, from s is equal to average speed into time, that is s is equal to u plus v by 2 into t. 2s is equal to u plus v into t, or u plus v is equal to 2s by t. This is expression P. Following, see from the first expression, first equation of motion, v is equal to u plus at. I rearranged this equation as v minus u is equal to at. First expression A. Now, from distance is equal to average speed into time, where average speed is u plus v by 2 into t, or 2s is equal to u plus v into t, or u plus v is equal to 2s into t. Right? Now, what should we do? Multiply A and B. Multiply A and B. See, all LHS side and RHS side. Okay? That is V minus U into V plus U is equal to AT into 2S by T. T and T gets cancelled. This is in the form of A minus B into A plus B. What is A minus B into A plus B? A square minus B square. Similarly, B square minus U square is equal to 2AS. This is the third expression. Understood? Simple. Okay? We took two equations of motions. From there, rearranging the conditions, multiplying. Okay? Once again, from equation 1, we got V minus U is equal to AT. And again from the expression S is equal, that is distance is equal to average speed into time. From there we got U plus V is equal to 2S by T. Multiplying A and B, we got V square minus U square is equal to 2AS. Okay? So, these are the three equations of motions. Understood? So, here we end the class today. In the next class, we do few numericals based on the equations of motions. Understood? Thank you.
ఏమైంది ఏమైంది నాకు ఫోన్ చేసాను ఏమో